Okay, I think I finally get how corner cutting actually works. And this is important because I've been working, this is the V3 of my printed cube. And the issue it has is reverse cutting is fine. It's about half a piece that it can occasionally cut like so. But the issue is the forward cutting is also basically just half a piece and not much more, if even. Right. So that's the issue with this. And I know that's an issue because standard speedcubes, 45 is easy. You can go like closer to 60, and with enough force you can still get it to cut. True for other cubes at different sizes. Even budget cubes can go past 45. And loose corner core mag modded cubes also very easily make the cut. So I knew it was something to do with tensions, obviously. Some tensions may help with corner cutting, but I mostly wanted to focus on the geometry that allows for corner cutting to happen in cubes, because even when you don't have magnets, like this Kenyon V2 doesn't have edge magnets, so it's really just non-magnetic. If you misalign it, it can still make these 45-degree cuts easily, even without magnetic alignment for all the other layers sustained. So clearly there's something geometrically about this, and even like an old Usual Metal Magic can also do 45 easily. Clearly there's something about the actual mechanism that I'm missing in the design here, because I don't think it's just the material. Right, so what is it? Well, how I figured it out, or how I believe I have figured it out, is I took out the corner piece on all my cubes, and I've just watched what happened as I made a cut from 45 degrees. And what it is that's going on, actually, is first the layer is rising. You can sort of see the whole face rises when it gets pushed on like this, because the edge has this torpedo hook that is directly in contact with the center, the base of the center. And so when you push on the edge, it pushes on the center, and all of the pieces are raised. The right side more so because you're pushing from the right side, but the whole face is indeed raised. At least from the front, it's starting to raise at least. And so what this allows is it allows more clearance for the pieces to rotate freely, so long as once it also raises, it begins to, this specific piece on that is in contact with the base of the center, it needs to raise the center, and then it needs to slip against the center in the direction that you're trying to cut. So first step is raise the center. Second step is begin to slip away from the top point of the center that it has raised to, and slip in the direction of the cut. And that allows you to make the cut. So what this actually means is that corner cutting is not about the corner. The corner being rounded in this way and the center being rounded in this way just ensure that after the edge has cleared, the corner can also clear because it will have been higher up, and this cutout here and this cutout here allow the corner and the center face to easily pass each other. But corner cutting is a function of, does the edge allow the cut to happen? And that's why mine, even though my corners look very similar, or somewhat similar to the corners on a speedcube, I'm still not able to cut at all. And the reason is because my edges are terrible. What is wrong with my edges? My edges follow the inverse of the rule that allows these cuts to happen on the corners. What is that rule? The rule is that the corners are not actually what is determining corner cutting, right? It's the edges. And so what do the edges actually need to do? When one edge is misaligned, the other edge must be able to move forward in a way such that the first thing that comes in contact for the two edges is this most rounded portion of the edge, the actual face of the edge, the internal face, not the face of the torpedo or the hook on the very bottom of the torpedo feet. These do not come in contact first. And what this allows is for the edge at its most rounded point to come in contact with the other. It allows the cut to happen because one edge will slip on the other edge. And this slip, once both are raised on the face, once we have raised the face to a new height and then allow the edge to slip against the base of the center, it also slips against the edge hook on this face, and that allows it to make the cut. The edge hook on this face, actually. It slips against it, and it proceeds to make the cut. That's what it does. It's because it comes in contact first with the most rounded portion of the internal face of the edge that allows it to slip once it has enough clearance, because the first move of the misaligned face allowed all of the pieces to rise. That gives it clearance, and then once these edges are in contact, it's critical that they're in contact at the most rounded part first, and because of that, they can easily slip on each other, and that's what allows corner cutting to happen. What was going on with my cubes instead? My 3D printed cube was catching, and the catching specifically was happening because when these edges came into contact, they first came into contact at these faces. And so what this allowed for was monstrous catches that you might be able to see in the V1 and V3 turns, especially the V2 turns. The V2 turns were this piece was extended equally out to basically the base of the corner, and they're still mostly extended out. But this made the contact immediately happen and caused edge catches. This isn't supposed to happen because these pieces are supposed to be further back or just built with different geometry such that it's these faces that are coming into contact first so that they begin to slip on each other, and that's what allows corner cutting. So that's the change you need to make. And I know this to be true because I can see this happening even on non-magnetic puzzles. So when magnetic alignment isn't even a factor here, it's you're raising this face, and then you're allowing the edges to slip against the center and the edges to slip against other edges that are misaligned, and that allows the cut to happen. So yeah, that's what I figured out. I'm going to use that for my upcoming design. What I'll do to update my edge is I'll basically go back to this edge and I will fill it off here because this is this portion of the surface, and this is the portion that needs to be rounded for when these two come into contact so that they can slip on each other and not get stuck on these points. And I also need to push these faces further in to ensure that this is indeed where they're coming into contact, not at the feet, but at the internal face. And that should allow corner cutting to happen if I understand what the speed cubes are doing and how to apply it to my design to ensure that my design will also be able to corner cut. So yeah, hope you enjoyed the rant. Obviously, other factors are at play in corner cutting when it comes to looser tensions that increases your opportunities for cutting, just because, again, the face and the whole as a whole has more opportunity to be misaligned if the center is closer immediately to contacting that corner, that top of the edge base. It will immediately be raised quicker, and so it will likely result in an easier cut and a higher cut possibility overall, just because it's raising earlier and it can raise to a greater height in the same amount of force. But I don't know how much of that I'll be able to implement into my speed cube without other issues such as this center cap starting to rise above the height of the edge and corners, which is a problem that I had previously experienced, but we shall see, and I'll give updates if corner cutting is still a problem for the cube or if I discover new things. But yeah, that was more on the geometry of corner cutting and its applications for speed cube design. Very cool that the edges are so tedious to design, even though they look like such simple pieces relative to all of the things, the diversity you see on the corners, but it's really the edge design as well as the center mechanism, how the edge can run on the center as well as how the edge can run against other edges, that determines how locky a cube is, basically. Really cool to learn that. So yeah, happy cubing.